Hey guys, let's talk about feature scaling. What is feature scaling? This is the secret to supercharge your machine learning model. The scaling of the features ensures that a feature with a relatively higher magnitude will not control the trained model. I know you didn't understood anything, right? Let me give you a simple example here. Imagine your house has a one tiny bedroom and a gigantic living room. Would you sleep comfortably? Probably not. Scale or the magnitude of the rooms are not really matching. So machine learning models face the same problem when features have widely different scales. That's where feature scaling comes to the rescue. If you're new here, I'm a mentor in the field of AI and machine learning. Started my journey 12 years back as a mentor, and during this time I got exposure to multiple technologies starting from Java to DevOps to Python to data science and obviously AI. And I have been helping corporates understand and implement the applications for the same. We have started a playlist of videos to understand everything about feature engineering, and this is I think 7th or 8th video. We have already seen data cleaning, imputation technique, categorical encoding and feature transformation in the previous video. So make sure you watch those videos first, because this video, which is feature scaling, is done towards the end of data pre-processing and just before giving input to the models. So in this video, let's deep dive and understand what is feature scaling, why feature scaling is so important, what are the different feature scaling techniques such as normalization, standardization, and many more. Understand their impact on the machine learning model, and definitely we're going to implement them using scikit-learn and the Jupyter Notebook. I think keeping the length of the video in the mind, we might divide this video into two parts. In the first part, we'll discuss about what and why and the importance of feature scaling. And in the second video, we will talk about how to implement the same. So stay tuned and make sure to watch this video till the end, and let's get started. Hey guys, welcome to AI with AI. This side, Asif Imnad. First thing first, let's talk about the need. Why feature scaling? Look at this picture. This picture explains everything. The gigantic sumo on the left hand side competing with the kids on the right hand side. Look at the magnitude in the strength. So we have two categories here, features with the higher magnitudes and the features with the lower magnitudes. Let me show you one more image here. Look at this image. The image of apple and strawberry. The size of the apple is relatively bigger than the size of the strawberry. So the upper part of the image is unscaled data. If I perform the scaling, you can see size of the apple and the size of the strawberry remains same without losing its intrinsic value, that is test, and its actual characteristics, right? That is what scaling stands for. Let me give you more technical example. Look at the data set here, which includes two key features: size of the house, which is in square feet, and number of bedrooms. If you observe, size of the house is given in the square feet, which is 800, 1200, 1500 square feet. And in the other column, the number of bedrooms is given, which is 1, 3, 2, 4. And what do you observe? The difference in the range is vast between two numerical features. To ensure that all features are given equal importance, we need to scale so that reasonable importance is given to the minor features as well, which is number of beds in this scenario. Why we are discussing this? Definitely variables with a bigger magnitude or the value dominate over the smaller magnitude or the value. And to prevent the machine learning algorithm from unbiased functioning, this is why we need feature scaling technique. But the question is, does all machine learning models gets affected because of unscaled data? Let me show you that. So generally speaking, the machine learning models where distance is measured, and distance is the major criteria to calculate the accuracy of the machine learning model, then feature scaling is really important. Like linear regression, logistic regression, where distance is measured between data points and the line drawn, right? Similarly, even in neural networks, in support vector machines, in KNN, in K-means clustering, linear discriminant analysis, or PCA, which is principal component analysis. In all these algorithms, we calculate distances. And you know what? The coefficients gets affected by the magnitude of the features. This is why feature scaling is really important. We don't want to draw a line which gets leaned towards the higher magnitude values, right? We need unbiased predictions. And where does feature scaling is not required? The machine learning models which are based on trees like classification, regression trees, random forest, gradient boosted trees. These algorithms are generally based on numerical calculations, and hence feature scaling is not required here. And that's why we need feature scaling in feature engineering pipeline for these reasons, which is nothing but to ensure uniformity and the balance between the features. It also facilitates better convergence during the model training. It allows the algorithm to take better predictions. It also helps boost the model's performance and the efficiency of machine learning algorithms, especially where gradient descent is used. Alright, I hope this helps you understand why feature scaling.
Okay, before we proceed and discuss in detail, if you are new here, don't forget to hit that subscribe button and the bell icon so that you won't miss our latest videos on AI. We see you are watching our videos, but 90% are not yet subscribed. We put lot of efforts creating these videos for you free. Keep us motivated by liking and subscribing, so YouTube algorithm will also help us reach more audience. So, did you subscribe and like? Thank you.
So now let's understand how do I perform and what exactly feature scaling is. Feature scaling refers to the method used to normalize the range of values of independent variables. In other words, the method to set the feature value range within the similar scale between 0 to 1 or -10 to +10, whichever scale you think is the best fit for the data. In between that range, you try to fit values of that column. Don't worry, I'm going to show you the demo towards the end. Stay tuned. But feature scaling is generally the last step in the data pre-processing pipeline, performed just before training the machine learning algorithm. As you can see in the image, this is just performed before you pass the data to our actual model, right? And we have seen how to perform data processing, wrangling, data extraction, data engineering. All of these steps we have already seen in the previous videos. Okay, but how do I achieve this? What are the different techniques to achieve feature scaling? So the most popular feature scaling methods are called normalization and the standardization. As you can see in the image, this is the actual data which is unscaled, drawn against X and Y. You can see after normalization, data is in between 0 and 1. You have the scale in between 0 and 1 on X-axis and also on the Y-axis. This is normalization. And in case of standardization, data is mean centered. And again, the data to achieve a range of 0 to 1. But how do we calculate the range? It cannot be only positive, it can also be negative by calculating mean and the standard deviation. How does it work? Don't worry about it. We are gonna see the demo for the same. But the important question is, does scaling have any effect on the intrinsic value of the features? Actually not. So feature scaling does not change the shape of the distribution. On left hand side, you can see the distribution. This is original scale. And the distribution plot is drawn for the house price prediction dataset. You can see the data distribution before performing standardization and after performing standardization. Looks same here, 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 and also here, house age. So distribution doesn't really change. So what really changes? If you observe, the data is mean centered now. The starting point for this column is 0, 0. If you see for here, it is 0 and -2 as well. If you see after standardization, the center is moved, right? Same for house age, right? 0, 1, 2, 0, -1, -2. But here, this is something different. Observe for latitude and longitude, 32.5, 35. But after standardization, data is range between 0, 1, 2, 0, -1, -2, right? So the data is mean centered now in between some specific range without losing its intrinsic value, meaning without losing its distribution. Even if I perform this on min-max scaler, which is one of the technique in normalization, you can see here, again, the distribution doesn't really change even in case of mean-max scaling, right? So you can see here, the data is between 0 to 15, and here data is drawn from 0 to 1, 0 to 1, 0 to 1, 0 to 1 for all the features, 0 to 1, even for latitude and longitude. Does that mean the shape of the distribution is changed? It is not. The intrinsic value should remain same. The plot should remain same. The benefit that I'm gonna get is unbiased magnitude and better performance and the efficiency to calculate the distances, and eventually machine learning model will be more efficient if you perform the scaling techniques, if you have already performed scaling on the data sets. And some of you might ask, what if I want to change the distribution? To change the distribution, there is a different technique which we discussed in the previous video, which is feature transformation. To change the distribution of the data, we use feature transformation technique, a logarithmic transformation, reciprocal, square root, Box-Cox, Yeo-Jonsson. So these are the different techniques we have already seen in the previous videos. If you have not watched, please go and see how do we convert our Skiff data to the Gaussian data. Alright, just to show you the result of performing feature scaling, I have executed this demo. We are going to see this demo in detail in the next video, but for now, just to understand what will be the result after performing scaling. That's why I'm showing you this output directly here. We have considered two features here and we have drawn a scatter plot, right? Don't worry about which data is considered. So this is without scaling. The green scatter plot which you see is without scaling, right? When data is drawn without scaling, you can see data ranges between 10 to 15 without scaling, and also for y-axis it is in between 1 to 6, right? So if I have performed standardization, which is in the pink color, you see data become mean centric, right? 0 to 2.5, 0 to 2.5, 0 to 3 on y-axis, and 0 to -2 on negative y-axis. This is mean centric data. And what happened with the normalization? When I performed min-max scaling on this data, you can see data is only here. The data range is converted only between 0 and 1. Okay, it is not more than 1 here, even on the x-axis and also on the y-axis. So the data which is drawn here and here is absolutely same. The distribution will be absolutely same. The only difference is the scaling, the magnitude. We are keeping the magnitude same. And this is the benefit of performing feature scaling. Alright, in this video, we have discussed feature scaling for machine learning, why and what is feature scaling and its importance. In the next video, definitely we're going to talk about techniques to perform the same and how do we do the normalization and the standardization.
And that's how we come to an end of this video. If you have any questions regarding the same, let us know in the comment below. If you found this video helpful, please subscribe to my channel and hit the like button, and don't forget to share this video with your friends and the colleagues. Thanks for watching. See you again next time. Till then, take care and bye-bye.